We have a tree, the hunter sitting in it. There's the hunter, with a young lady is gonna try hunt whatever animal you want that to be. We call it deer, but it doesn't look like a deer. There's the antler and a 3-4 point. So the arrow was fired from the tree to the deer. And we said, let's assume it hits the deer at 1 meter above the ground. So this height is 1 meter. That's why I drew on the board. And we said the person was sitting how high in the tree? 15 meters, okay. And you fired the arrow pointing down. This angle was 20-degree angle. And the initial velocity the arrow left is
3.5.
35, I mean.
35.
Yep. 3.5 won't go that far, won't kill it. Better go flying if you want to pierce it there. And we asked 3 questions actually. What is the distance? Where was the deer distance-wise from the edge of the tree? So what's that distance, x? Find x. Find the time it took for the arrow to travel from the hunter to the deer. And what is the velocity when that arrow hits that deer? Again, the fact you're going up and down, left to right, in both direction, we have projectile. Let's break it down to the x direction. And the y direction. Let's write what we know. In the x direction, what was your initial velocity or speed? $35? Just 35?
35 cosine.
Yep. Cosine what? 20. Or negative 20. Because that'll make the y velocity being negative, meaning pointing down, not up. So in the x direction you find cosine of negative 20. So you find that's 32.9 meters per second. But in the y direction, it will make a difference if you use positive versus negative, because if you use positive, you're assuming the arrow was shot up in the air and it came down. God, what's these noises? 35 sine negative 20. So it's negative 11.97, about 12. We'll say 12. It's negative 11.97. That's 12. You can use anything you want to use for reference. What do you want to use for reference? You tell me. The ground, the top where the hunter was standing, the deer. What do you want to use for reference? Will make a difference. Pick one. We need to go home in 1 hour, 2 hours, so.
The ground.
The ground? So what's my initial height where the hunter was sitting? 15. What is my final height?
1.
1. What's the acceleration?
Negative 9.21.
negative 9.8. Can I find the time? Because if I know the time, I can come back to this and find x. Remember, there's only one equation in this direction. So I need the time. I have V0 here. If I know the time, I can find x. So let me find the time first. That would answer one of the questions. I'll come back and find x. That will answer the other question. Then I can go back and find the velocity, which is the third question. Again, we're going to look and see which equation. Fourth one to solve for t. The fourth one says y equals y sub 0 plus v0t plus 1/2 at squared. Y is 1, 15, v0 negative 12 times t, 1/2 negative 9.8 t squared. That's a negative here if you can't see it. Again, I like to move everything to one side. I will have 4.9 t squared plus 12t. This would be negative 15 plus 1 negative 14 equals 0. As I said earlier, quadratic equation does not intimidate me, so I'm okay with math. So maybe I'll use the quadratic formula to solve that one. So I'm going to use t equals negative b plus or minus the square root b squared minus 4ac divided by 2 times a. Minus a 12, that's a negative 12. 12 squared minus 4 times a, which is 4.9, times t, which is negative 14. 2 times 4.9, which is 9.8. Let me take the square root of that number, do the whole thing in one shot, multiply them and add them and take the square root. That's the square root of 418.4. $20.45 or 20.5 over 9.8. One of them is going to be with the plus, one is going to be with the minus. Negative 12 plus that number. .86 seconds. The other one, negative 12 minus 20.49. Doesn't really matter, that's a negative number, but we'll do the math. The other time is negative 3.31 second, and that doesn't make any sense, that negative time. So the only time that makes sense, so how long was the arrow in the air? 0.86 second. Next question, what was x? X equals what?
B.
v0 times t. We know the initial velocity in the x direction. We calculated that one to be what? 32.9. We know that the time, which is what? 0.86. I guess that deer was not that far. It's about 28.3 meters. Now, if you use by mistake, if you don't put the minus here, made that a plus, your time is going to be much larger than 0.86, which will make that distance obviously much bigger. And the last question, what was the velocity when that arrow hits the deer? Well, keep in mind, the velocity in the x direction stays the same. I need to know the velocity in the y direction. So here's the arrow. I know the velocity in this direction stayed the same. In the x direction, that velocity is constant, 32.9 meters per second. So let's find the velocity in the y direction. Again, it should be negative because you're shooting down. That velocity in the y direction. Let's see if we can get that. We know the initial velocity in the, let's go back to the y direction. We know the initial velocity was negative 12. We know the acceleration was negative 9.8. We know y0 and y final. Can I get the final velocity? So let's see. Which equation? Maybe 5. Oh, great. Now we start drilling holes here. Negative 9.8, 1 minus 15, which is negative 14. This will be a plus. That's a negative. That's a negative. Now, when you have something squared equals a number, mathematically, it's always two answers. One is positive, one is negative. God, it's so noisy out there. So the velocity, one is positive, one is negative, mathematically. But in this case, is the arrow moving up or down? You have to shoot up or down? Down. So you go, when it hits it, it was moving down. So the velocity better be what? Negative 20.45 in the y direction. So it's 20.45, the negative to tell you it's coming down. It was coming the y direction. So that's the final velocity in the y direction, and this is the final velocity in the x direction. If you just want to find the velocity and the angle, I don't care about x and y. So what is that v and what's theta? Then I'll use vectors. I know the x and y component. Can you find what v and theta is? The x component square and the y component square. So let's see, the square root of 32.9 squared. 38.7 meters per second. That's the velocity. And the direction, or the magnitude of it, the direction is the inverse tangent of the y value over the x value. What is your y here? Negative 20.45. What's your x? 32.9. Notice I'm in the fourth quadrant. There is no addition of 180. Negative 31.9 degrees. So that's the velocity, actually, v and theta. If you want, again, if you want it in x and y component, you can say the velocity here has 32.9 in the x direction, negative in the y direction, 20.45 in the y direction. So you have the x and y component, and what we did, we took the x and y component and try to find that, change them using Pythagorean theorem, find v and find theta. How many of you get that one right? Anyone? Okay. I'm going to put another one. I'll give you 2 minutes to think about it because the camera is running. Then I'll do it. I'm going to do 2 more, I guess. The last one, I'll do it, and then maybe I'll give you another one to try. I was looking earlier in the book to see if I can find just different examples. And I saw something with baseball here. So let's look at this one. Could be softball too for ladies who play softball. Playing shortstop. It says you pick up a ground ball and throw it to second base. Listen to this one. The ball thrown horizontally with the speed of 22 meters per second. So you picked up the ball and you fired horizontally in that direction. At speed of 22 meters per second. Well, what's going to happen to that ball if you fire it horizontally is not going to go like this. It's going to start to drop. As it's traveling, it will drop because gravity is pulling down on it. Now, what happens, the second baseman caught that ball. So that's the second baseman here. We know the time in this example. The time is 0.45 seconds. And the first question is, what's the distance between the shortstop and the second baseman? What is that distance, x? And the second question, the ball dropped, the second baseman caught the ball here. So what is that drop here? Let's call that, I don't know, what, y? What is y? How far did the ball drop? When the second baseman grabbed it, hopefully it wasn't on the ground. What is the distance of vertical drop, A to B, from here to there? What is y? So let's look at that. Again, we have a projectile. Here's what it looks like it. The ball is traveling like this. Maybe I'll, because I don't know the ground, maybe I'll use this as reference here. Bless you. I threw the ball in that direction, so that's going to be my reference for the height. Let's see. What do we know about the x direction? Do we know the initial velocity? No. Right? We don't know what x is. We're looking for it. Do we know what the time is? 0.45 seconds. Do we know what the initial speed is? You sure? Is there cosine, sine?
Oh, sure.
It is 22. Just because I asked it doesn't mean you were wrong. Why is it 22?
There's no angle.
Yeah, because it was fired horizontally, angle 0. So even if you wanted to use that, what's 22 cosine 0? 22. What's 22 sine 0? 0. Because when you fire horizontally, even if you still want to use the value times the cosine for x, the value times the sine for y, that still works. Cosine of 0 is 1, and 22 times the 1 is 22. So I know what my distance is. That's the first question. There's only one equation in the x direction. .22, and what was the time? 0.45 seconds. 9.9 meters. A bit over 10 yards. So when the short stopped through the ball to second baseman, they were 9.9 meters away from each other. Question number 1, done. Question number 2, how much did the ball drop? Let's see, in the y direction, what's the initial velocity in the y direction? Up and down. When that ball left the shortstop hand in the y direction, what was the velocity in the y direction? 0. If it's horizontally, 0. The acceleration once the ball leaves that shortstop's hand, the acceleration is gravity. If I use this as reference, the top, what was the initial height? The initial height. Let me call it B instead of Y, so you don't get confused here. What was my initial height? How high or low, above or below this reference line initially? Here's the ball in my hand. I'm the shortstop. In relation to that line, how many meters above or below that line am I? Look at that picture there. There's the ball. How high, how much above this line or below that line that ball is? 0. The final height. Where is the ball? How far the ball here in relation to that height? How many units above or below that line? It's what? B units, because I don't know what B is. I'm looking for it. B units is above or below?
Negative.
So that's a negative B. I also know the time. That was given the problem. And now let's see if I can solve for B here, or Y. Y is the unknown. I could have just left it as unknown here. If you don't like to use B, you can use question mark here. If you don't want to put B, just say, I'm looking for that. But your answer should be a negative because below that line. So if you don't want to put B, that's fine. Just go, I don't know what the value is, solve for it. So which equation I can use to solve for that? It looks to me equation number 4. We're looking for y, it's unknown. Y sub 0 is 0. V sub 0 is 0. 0 times anything is 0. Negative 9.8 times 0.45 squared. It looks like almost 1 meter, huh? With the minus. So the person caught the ball 1 meter actually below, almost to the ground there, well, to their knees, when the shortstop got that ball. Next time you watch baseball, watch when the third baseman or the shortstop throw the ball. It's never horizontally. If you want the person on the other end to catch it comfortably, well, comfortable means right there at their chest. You do not want to throw it right at their glove there because the ball will sink in. So what you have to do, throw it with a little arch in it. So when that person gets it right there. If you throw it horizontally, he will never or she will never get it right there. If you just fire it in that direction, it's going to go. And if you fire away, it's going to hit the ground, then you're trying to scoop it there. Or you're making an uneasy catch for them, so you always put a little arc in it there. So when the person gets that ball, gets it at a nice height, you can grab that ball and take it. Let me try another one, then I'll give you a couple more to try. As I said earlier, if you want to maximize your distance x, if you want to maximize it, you really want to throw it a 45-degree angle. Just to show you some pictures here. I can't zoom in. I can't even focus once I start the video. I redraw these. They're showing you pictures what will happen if you fire something at 45-degree angle like this. It's going to go the farthest distance that you can get. That's called maximum distance. That's a 45. If you're a golfer, you will notice actually each club has a different pitch on it, different angle, because they want you to hit with the same swing. So if you hit a 45, it's always going to go that far. Well, what about if I don't want to go that far? I want to land closer. Then I'll pick a club that has a bigger angle. So instead of 45, I might hit it at 60. If I hit it at 60, it will go higher, and it lands right there. That's a 60 degrees. If I hit it at 25 degree or 30 degrees, the ball is not going to go as high, and it will go like this. Let's say this is 25 degree. So for maximum distance, if you want to reach the longest distance possible, you want, for maximum distance, You want theta to be 45-degree angle. Anything else, you will not reach the maximum distance. Again, sometimes you don't want to reach the maximum distance, like in golf. You hit it the first time, you get 300 yards, and now you just want to get 100 yards. You're probably going to pick, a 9 or a pitching wedge and hit it so the ball will go high in the air and land 100 yards away. It will go really high and come down that way. If you got a lot of trees in the way, then we're going to alter that shot there. So let's see if I can take an example. Find one on maximum distance. Otherwise, I got to think of one, which is not a big deal. But if I can find one, I don't have to think. Okay, let's try this one. I'm making this one up. Again, we have a tree. And we have this branch dangling from a tree. So you decide to tie a rope to that and make a swing out of it. So this is water here. Here's my story. So you grabbing the rope and you swinging from the rope there. So what do we know in this story? When you let go of the rope, you happen to be moving in this direction. Your initial speed, 3 meters per second. And since your goal was to go as far as you can, you managed to figure that angle and you jumped at 45-degree angle. It's going to go like this. And you're going to land there. I was able to give you some numbers, but let's ask a few questions because I'm trying to think if I put some numbers, it might not work out. So let me just do everything. How high were you above when you let go? What's that height? What's that initial height? If I use the water as reference. And where did you land in relation to that spot? How far? So find y sub 0 and x. You managed to hit it right on the money, a 45-degree angle. So you're going to go the farthest distance possible. Okay. Let's look at the x direction. Let's look at the y direction. Projectile, always break it down to x and y direction. What's the initial velocity in the x direction? What's the initial velocity in the x direction?
3 cosine.
Yep, 3 cosine. 45-degree angle. Is that 2.3 maybe? 3 cosine 45. 2.12 meters per second. What's the initial velocity in the y direction? 3 sine of 45. That also happens to be 2.12 meters per second. Time is not given to us. Again, only one equation in the x direction. I know what V0, 2.12, so I need the time to finish that problem, to get x. Without the time, I can't do it. Let's look at the y direction. What else do we know? Jimbo, how you doing? What's our acceleration? Good. Someone on a swing, jumping from a swing, that's a tree. The person let go at 45-degree angle, just like in golf, to get the maximum distance.
Yeah.
So we're going to see how far it's going to land. What was the initial height?
That's dangerous.
Well, you should see the one before that. We had a hunter sitting in a tree shooting Bambi.
Oh, no.
There it is. Where's that hunter? That took. Where's the picture of it? God. On.
Oh, this thing? Oh, right here?
Yeah. See that? He's hiding in the tree shooting that deer. Dinner for you tonight, Mr. McDonald. It's negative 9.8, the acceleration.
It is?
Yep.
Maybe
Well-
they change that.
What was the initial height when she released that rope? Unknown, yes. What's the final height when she hits the water? 0, good. And I'm looking for the time. I know they're not asking for the time here, but if I want to find x, I need to know what the time is. I also need to find what? Y sub 0, right? That was given. That's one of the questions. I made this one up, so this might be a little problem. I don't know if I gave you enough, everything we need. Okay. So to get the time, let's try the time first. So I can finish and get this one. So what can I do? Can I use this equation? Y equals y sub 0 plus V0t plus 1/2 AT squared. Notice I got a little problem there. How many unknowns in that one? 2. So I can't really solve that. V0 was at 2.12. So I have 2 unknowns there. So I'm out of luck here. I can't use that one. What other equation maybe I can use? There's the velocity, but that doesn't help me. What about equation number 5? That won't help me either. Let's wait on this. Let's see. Let's look equation number 5. I screwed up. I should have given you something else. I should have given you the time for that problem and ask you for the other questions. If I gave you the time, I can find all these. I don't even know if the problem is doable, but I gotta try it at least. I just make things up without thinking about them. What's V0 here? 2.12 plus 2 times negative 9.8 y, which is 0, minus y sub 0. I got to try everything to see if it can be done with the information I gave you. 4.5. This will be a plus 2 times 9.8. That's at 19.6. Notice that's another equation that has how many unknowns in it? 2. The problem with that, it's not the same unknowns even. If they were the same unknowns, I can use substitution, but that doesn't do me any good. And you say, what about if you grab the top equation? That will have V and T in it. So anywhere you slice it, it's not really working out for this problem. So if I want it to work out, I have to modify the problem a little bit there. I might have to come back to this because you know what? Let's change the question a little bit. I screwed up there. Let's say the person was, let me give you the time then. The person was in the air for, because I left something out. I'm not giving you enough information. But let's say it took the person 0.75 seconds to hit the water. Now if I give you that piece, can we solve it? If I give you the time, I can find x immediately now. Because I come back to this, I know what my time is, 0.75. .59 meters away. Can I find y sub 0? Let's go back to this equation. If I know what t is it, can I find y sub 0 now? So take this equation, let's plug it in. So when you make a question, when I sit down and make questions off the top of my head, Sometimes I don't do a good job with them. You see that example? Like I didn't give you enough information to solve that one. 2.12 times 0.75, 1.59, 4.9 times 0.75 squared, 2.76. So 0 equals y sub 0 minus 1.17. So what is y sub 0 equal to? 1.17 meter. So if I gave you the time, then I could have found all the questions, any question. I can find the velocity once I know y sub 0. Or I could use the top equation, v equals v0 plus at. You know the acceleration, you know the time, you know the initial velocity, you can find the final velocity. So if the time was given to us in that example initially, it would have been a piece of cake. By trying it without the time, I found out I couldn't solve it. Every equation I got, I had two unknowns in it, which means I didn't give you enough information for that problem. So that's why I had to go back and say, well, let's go back and modify it. Let's say we know the time. And once I gave you that piece, then the rest is history. Or let me give you the initial height. If I gave you the initial height, I could have solved for the time here, come back to it here, finish this, and do the other stuff. But I have to give you something else.